Okay, today I'm going to talk to you about absolute zero and the Kelvin scale of temperature. So to understand absolute zero, we need to understand how particles work. So when you increase the temperature of something, you give the particles more energy so they can move around faster or vibrate more. So the higher the temperature, the more their movement. So if you decrease the temperature, their movement becomes less and less and less. So as it gets colder and colder and colder, the movement of these particles decreases and decreases. They have less and less energy. Now, eventually, if you keep on cooling these particles down, eventually they will essentially have no energy at all, or next to no energy at all. And this is called absolute zero. You cannot get any colder than that. It is minus 273 degrees Celsius. So we're talking really, really cold. At this temperature here, that's the coldest that there can be, because you can't have any less energy than no energy at all. So if the particles have stopped moving altogether, or essentially stopped moving altogether, then we have this idea of absolute zero. So how does the Kelvin scale of temperature come into it? So Kelvin is just another temperature scale. So you could have degrees Celsius, you can have degrees Fahrenheit, you can also have Kelvin. Please notice that it isn't degrees Kelvin, it's just K for Kelvin. So the way that the Kelvin scale starts is 0K is at absolute zero. So 0K is minus 273 degrees C. Now, to help understand this, we're just going to have a look at this thermometer here. On this side, I'm going to show Kelvin. In fact, I'll just show you how that's written, like that, Kelvin. And on this side, I'm going to have degrees C, because a change of 1 Kelvin is the same as the change of 1 degree C. The only difference is their starting point. Let's have a look at this example. So 0K is the same as minus 273 degrees C. If we go up by 1K, we also go up by 1 degree C. So this time it's minus 272. 271, 3 Kelvin is 270, and so on. So as you can see, the difference of 1 Kelvin is the same as the difference of 1 degree C. The only difference between the two scales is their starting point. Degrees Celsius starts at 0 degrees C, which is the freezing point of water, or the melting point of water, and 0K is absolute zero. Let's just have another look at another example below here. So if I'd imagine I have 0 degrees C here, just up 1 I'd have 1 degree C, 2 degrees C. This would be minus 1 and minus 2. So 0 degrees C is 273 Kelvin, which means 1 degree would be 274. That would be 275, that would be 272, and that would be 271. So, if you're a little bit confused about how I got these numbers from these numbers, here's just a quick way of showing how you convert from degrees Celsius to Kelvin. So if I'm converting from degrees Celsius to Kelvin, I just need to add 273. And if I'm converting the other way, I just do the opposite. So I just take away 273. I'll just show a couple of examples underneath. So let's say I wanted to show 25 degrees Celsius in Kelvin. So let's have a look at this up here. What I need to do, I'm starting with degrees Celsius. So to get to Kelvin, I just need to plus 273. So the answer to that is 298K. So it's a nice, easy conversion to get from one to the other. Let's do it the other way round. Let's say I wanted to know what 100 Kelvin was in degrees Celsius. So because I'm going from Kelvin to degrees Celsius, I need to take away 273. So the answer this time is minus 173 degrees C. So just to summarise, absolute zero is the point at which particles have so little energy, they basically have no energy at all, they do not move. The start of that absolute zero scale is the start of the Kelvin scale of temperature. The change of 1 degree is the same as the change of, 1 Kelvin is the same as 1 degree Celsius. And here's a nice easy way of converting between the two. Thank you.